All right, welcome back. We're reading about fault tolerance. Fault tolerance is a fascinating topic, but it can be very confusing. What is meant by fault tolerance and how can you achieve it? A great place to learn more about fault tolerance is to read as many white papers from AWS as you can. When designing fault tolerant systems, it's useful to start by trying to answer the following question. When this service goes down, what can I implement to eliminate or reduce manual interaction? Nobody likes getting notifications that a critical system is down, especially when this means numerous steps to recover, even less when it takes communication with other services to ensure everything is back to normal. Note that the question is not being framed as an improbable event, the question being, what can I implement to eliminate or reduce manual interaction? It explicitly acknowledges that the service will go down and that some work will needed done to get it up and running. Okay, so sorry, I had to do something else this morning and cut the video short, but one of the things I was really questioning is, am I going crazy and just not able to read anymore, or is the quality of this book starting to go way downhill? And this is our fourth major grammatical error. It explicitly acknowledges that the service will go down and that some work will needed done. They meant to say some work is needed to be done, or some work will need to be done. Some work will need it done is really infuriating. So it's not me. This book is getting bad. I'm going to try to power through it, but my last book I read through, Mastering Amazon, I ended up just stopping reading it because it was just reading like an advertisement for tools that I could just go and read the documentation for that tool and not waste my time reading the book. But we're going to keep going ahead with this. A while ago, a full redesign of a complex build system was planned. The build system did several things, most of them related to packaging and releasing the software. Dependencies had to be in check. Make and other tooling built binaries. RPM and Debian packages were produced. And repositories for different Linux distributions like CentOS, Debian, and Ubuntu were created and hosted. The main requirement for this build system was that it had to be fast. Although speed was one of the primary objectives when designing a system that involves several steps and different components, it is useful to address the known pain points and try hard to prevent new ones. There are always going to be unknowns in large systems, but using the right strategies for logging and logging aggregation, monitoring, and recovery are crucial. Turning our attention back to the build system, one of the problems was that the machines that created the repositories were somewhat complex. An HTTP API received packages for a particular project at a specific version, and repositories were generated automatically. This process involved a database, a RabbitMQ service for asynchronous task handling, and massive amounts of storage to keep repositories around, served by Nginx. Finally, some status reporting would be sent to a central dashboard so developers could check where in the build process their branch was. It was crucial to design everything around the possibility of this service going down. A big note was added to the whiteboard that read error. The repo service is down because the disk is full. The task was not necessarily to prevent a disk from being full, but to create a system that can continue working with a full disk. And when the problem is solved, almost no effort is required to put it back into the system. The full disk error was a fictional one that could have been anything, like RabbitMQ not running or a DNS problem, but exemplified the task at hand perfectly. It is difficult to understand the importance of monitoring, logging, and sound design patterns until a piece of the puzzle doesn't work. And it is impossible to determine the why and the how. You need to know why it went down so that prevention steps can be instrumented, alerts, monitoring, and self-recovery to avoid this problem from repeating itself in the future. To allow this system to continue to work, we split the load into 5 machines, all of them equal and doing the same work, creating and hosting repositories. The nodes creating the binaries would query an API for a healthy repo machine, which in turn would send an HTTP request to query the health endpoint of the next build server on its list. If the server reported healthy, the binaries would go there. Otherwise, the API would pick the next one on the list. If a node failed a health check 3 times in a row, it was put out of rotation. All a sysadmin had to do to get it back into rotation after a fix was to restart the repository service. The repository service had a self-health assessment that, if successful, would notify the API that it was ready to work. Although the implementation was not bulletproof, work was still needed to get a server up and notifications weren't always accurate. It had a tremendous impact on the maintenance of the service when restoration was required and kept everything still functioning in a degraded state. This is what fault tolerance is all about. And that makes sense. It's the right words for it. When there's a fault, when there's something going wrong, it can still tolerate that fault and function, but you have advance notice and warning to go and take care of that before the system actually goes down. And that's alternative to a system that doesn't have fault tolerance, where as soon as there's a fault, the whole thing's down. You don't even get a notification as to why it's down. You're just completely out of luck. All right, next section is monitoring, but I need to take a quick break. I'll be back shortly. All right, I'm back. Next section is monitoring. Monitoring is one of those things where one can do almost nothing and still claim that a monitoring system is in place. As an intern, Alfredo once used a curl cron job to check a production website, but can grow to be so complicated that the production environment seems nimble in comparison. When done right, monitoring and reporting in general can help answer the most difficult questions of a production life cycle. It's crucial to have and difficult to get right. This is why there are many companies that specialize in monitoring, alerting, and metric visualization. At its core, there are 2 paradigms most services fall into: pull and push. This chapter will cover Prometheus, which is a pull service, and Graphite with StatsD, which is a push service. Understanding when one is a better choice than the other and the caveats is useful when adding monitoring to environments. Most importantly, it's practical to know both and have the ability to deploy whichever services will work best in a given scenario. Reliable time series software has to withstand incredibly high rates of incoming transactional information, be able to store that information, correlate it with time, support querying, and offer a graphical interface that can be customized with filters and queries. In essence, it must almost be like a high-performing database, but specific to time, data manipulation, and visualization. Graphite. Graphite is a data store for numerical time-based data. It keeps numeric information that correlates to the time it was captured and saves it according to customizable rules. It offers a very powerful API that can be queried for information about its data with time ranges, and also apply functions that can transform or perform computations in data. An important aspect of Graphite is that it does not collect data. Instead, it concentrates on its API and ability to handle immense amounts of data for periods of time. This forces users to think about what collecting software to deploy along with Graphite. Oh, so in addition, so Graphite doesn't actually collect the data. It just gives you the means to collect data, so you need to use another piece of software to actually collect the data. There are quite a few options to choose from for shipping metrics over to Graphite. In this chapter, we will cover one of those options, statsd. Another interesting aspect of Graphite is that although it comes with a web application that can render graphs on demand, it is common to deploy a different service that can use Graphite directly as a backend for graphs. An excellent example of this is the fantastic Grafana project, which provides a fully featured web application for rendering metrics. Okay, so we've got Graphite, we've got Grafana, we've got statsd. Okay, so the next section is statsd. Graphite allows you to push metrics to it via TCP or UDP, but using something like statsd is especially nice because there are instrumentation options in Python that allow workflows such as aggregating metrics over UDP and then shipping them over to Graphite. This type of setup makes sense for Python applications that shouldn't block to send data over. TCP connections will block until a response is received. UDP will not. If a very time-expensive Python loop is being captured for metrics, it wouldn't make sense to add the time it takes to communicate to a service that is capturing metrics. In short, sending metrics to a statsd service feels like no cost at all, as it should be. With the Python instrumentation available, measuring everything is very straightforward. Once a statsd service has enough metrics to ship to Graphite, it will start the process to send the metrics over. All of this occurs in a completely asynchronous fashion, helping the application to continue. Metrics monitoring and logging should never impact a production application in any way. When using statsd, the data pushed to it is aggregated and flushed to a configurable backend, such as Graphite, at given intervals, which default to 10 seconds. Having deployed a combination of Graphite and statsd in several production environments, it has been easier to use one statsd instance on every application server instead of a single instance for all applications. That type of deployment allows more straightforward configuration and tighter security. Configuration on all app servers will point to the localhost statsd service, and no external ports will need to be opened. At the end, statsd will ship the metrics over to Graphite in an outbound UDP connection. This also helps by spreading the load by pushing the scalability further down the pipeline into Graphite. Note, statsd is a node.js daemon, so installing it means pulling in the node.js dependency. It is certainly not a Python project. Prometheus. In a lot of ways, Prometheus is very similar to Graphite. Powerful queries and visualization. The main difference is that it pulls information from sources, and it does this over HTTP. This requires services to expose HTTP endpoints to allow Prometheus to gather metric data. Another significant difference from Graphite is that it has baked-in alerting, where rules can be configured to trigger alerts or make use of the alert manager, a component in charge of dealing with alerts, silencing them, aggregating them, and relaying them to different systems such as email, chat, and on-call platforms. Some projects like Ceph already have configurable options to enable Prometheus to scrape information at specific intervals. It's great when this type of integration is offered out of the box. Otherwise, it requires running an HTTP instance somewhere that can expose metric data for a service. For example, in the case of the PostgreSQL SQL database, the Prometheus exporter is a container that runs an HTTP service exposing data. This might be fine in a lot of cases, but if there are already integrations to gather data with something, such as collectd, then running HTTP services might not work that well. Prometheus is a great choice for short-lived data or time data that frequently changes, whereas Graphite is better suited for long-term historical information. Both offer a very advanced query language, but Prometheus is more powerful. For Python, the Prometheus Client is an excellent utility to start shipping metrics over Prometheus. If the application is already web-based, the client has integrations for lots of different Python web servers, such as Twisted, WSGI, Flask, and even Gunicorn. Aside from that, it can also export all its data to expose it directly at a defined endpoint versus doing it on a separate HTTP instance. If you want your web application exposing in metrics, then adding a handler that calls Prometheus Client.GenerateLatest will return the contents in the format that the Prometheus parser understands. Create a small Flask application, save it to web.py to get an idea how simple generate_latest is to use. And make sure to install the Prometheus client package. All right, let's do it. So I've got my lab here. So they're not going to give a lot of detail here. I'll move the bookmark forward. Okay, and then come back here. So we're going to need a Python package. So let's create a virtual environment. And let's make it inside. So let's make a folder called. Oh shoot. Let's make one called test, and then we'll change to test, and we'll do Python 3 VNV -m VNV. Do I not have Python in here? I guess I don't have Python. Okay. I guess I could just do this on my on somewhere else, but you know what? This is going to be fine doing it on here. Looks like we're getting 3.5. I think the current version is 3.8, so I'm not sure why it's pulling such an older version. But 3.5 will be perfectly fine. Usually VNV comes with Python 3, so I'm not sure what's going on there, but looks like it's just another apt-get install command away. Okay, now we got the virtual environment, so let's see if we can pip install Prometheus. And we can. Alright. So let's make the Flask application. It'll be called web.py. Okay, so this is a decorator, so I think this line goes here. Okay, and then this is a function here, response, probably a class, but we're gonna pass it some arguments. Oh, and we're gonna have some spaces here. There we go. All right, that looks good to me. Next step is to run the app with the development server. So I don't have Flask, so I don't think this will work. We'll try it anyway. Don't have it. Oh, I did Flash instead of Flask. Still don't have it. I think it's a Python package. Yeah, it's a Python package. Oh, something happened. It looks like line 11, or let's see what happened in the, here's the files it's tracing back through, so let's look for the web.py file. I don't see it. Oh, here it is. Oh, never mind. Okay, so it looks like it's just an issue with Flask. It looks like Python 3 was configured to use ASCII 2 as encoding for the environment, but I tried to get it to use UTF-8. So let's see if we can go to this website and figure this out. Okay, so I'm on a US machine, so it looks like all I need to do is run these two lines here. All right, perfect. So hopefully that fixed it. It's another example on why error messages are so good, because you can get your problems solved really fast. Okay, it looks like in my... in line 1 of my file here, I've got a typo. I used Flash instead of Flask. I used Flash a number of times. Okay, finally it's working. Okay, so run the app on the development server. So we're running it on the development server. Yeah, we got the warning. While the application is running, open a web browser and type in the URL. Now, the thing is, I don't think that's going to work. Yeah, that's not going to work. Like, it would only work if I could type in the URL on this machine, but this machine here doesn't have, what's the word I'm looking for? It doesn't have a GUI, so this is just not going to work. I guess what I can do is like a grep for this, and then see if I can like change it, or like go to bin, or okay, maybe I can go in and change some of the config files here, or something. Okay, so here's config.py. See, I want to try to change the IP. Yeah, I want to change this. Let me try this actually. Okay, so this is the OpenBSD secure server. It looks like in following some of the other instructions, I installed a OpenSSH server. So I'm gonna remove that because I'm gonna use the OpenBSD server instead. All right, and hopefully I can now SSH. I can, sweet. Okay, and I don't have a password set up, or I don't know what it is. I forget the command off the top of my head how to set up a username and password. User add. Okay. Okay, so now I'm in. So I think what I can do is forward. Huh, that's interesting. Oh, I'm not in the right. Yeah, I gotta go here. There you go. Perfect. Okay, now is this gonna work, or do I have to forward the port? Not gonna work. Oh, is this it? I think I might have done it. That would be amazing if I did that. Sweet, I did it. Yeah, so you can see now that I'm doing I'm forwarding a port. So I'm forwarding port 500. So from port 500 to port 500, I think that's how that goes. But now I can actually send get requests over to my server here, because this server is running on the local device here on port 500, but my personal laptop that has the browser open on here is now SSH'd into that server, and that server is forwarding all of this information on. So it's as if I was pulling up a browser on this machine here, but instead I'm pulling it up on my machine because this machine is connected to my machine because my machine is forming an SSH session to that machine that forwards this over on a port. I can't believe I got that to work. I've always kind of struggled with figuring that out, but it looks like I truly figured this out, which is awesome. Cool. Okay, so let's do a netstat. And let's do a -n, of course. So there's no... Okay, so here's the connection. My computer is here. The lab is... Oh, there's actually more than... Yeah, there's... Oh, this is the only established connection, though. That's weird. Why is that the only established connection? I guess it's because I haven't... shoot. Yeah, like if I refresh this a bunch of times, oh, that's weird. Yeah, I don't know what's going on there. Oh. There we go. Okay, so now we're printing this out every second, so let's see if there's any... Okay, so I get more... Okay, there we go. Yeah, so you can see my local address, the VM I've got in my lab. It's on 5,000, but now I'm forwarding that over to this machine here, which is, yeah, so I can't believe I got that to work, but I did. I'm just wondering if I got it to work correctly, if I got it to work in like a hacky way. That's not going to work. But let's keep on going. While the application is running, open a web browser and type in the URL. Okay, so let's go to /metrics. There we go. Oh, wow, this is cool. It starts generating output that Prometheus can collect, even if there is nothing really significant. Most production-grade web servers like Nginx and Apache can produce extensive metrics on response times and latency. For example, if adding that type of metric data to a Flask application, the middleware, where all requests can get recorded, would be a good fit. Apps will usually do other interesting things in a request, so let's add 2 more endpoints, one with a counter and the other with a timer. These 2 new endpoints will generate metrics that will get processed by the Prometheus Client library and reported when the metrics endpoint gets requested over HTTP. Adding a small counter to our small app involves a couple of small changes. Create a new index endpoint. Okay, so let's look over what we got here. We got some comments here. Then we got some actual objects. But I don't see anything. Oh, here we go. We've got like virtual memory. So that could be useful. We've got the memory size. Total user and system CPU time spent, that could be useful. Yeah, we got a Python version here, version 3.5. So yeah, already useful information without any extra customizations or anything. So let's update our file. And I'll have to keep that window running. I'll have to maintain my connection. You can see our log here. Oh, we did get a 308. I guess I'm not sure what that is. But Let's add some more information here. Okay, so remote forwarding in open. Okay. Oh man, I forgot to pause it. Oh no, I forgot to unpause it. Did I forget to unpause it or did I forget to pause it? Oh, I forgot to unpause it. Okay, so every once in a while I've been pausing these videos momentarily for unexplained reasons. I forgot to do that recently, so let's just not speak to that any further and keep going on. Now I'm confused here. Oh, okay. We're gonna add to the file here. Sorry, I lost my focus here. Okay. Okay, we're gonna add a new counter. Okay, that looks good to me. Now define the counter object. Add the name of the counter requests, a short description, application request count, and at least one useful label, such as endpoint. This label will help identify where this counter is coming from. Okay, so we gotta add okay, we got to define the counter object now. This is not written very clearly. I'm lost. So is this still in the webpy file, or is it a new file? Do we need to? So do we need to continue to add more lines to this file, or? Is there a new file? I'm really confused here. Okay, I guess I'll just add this to the file. So I'll add a new line here under these import statements. I'm not sure why they're doing it this way because we already imported Prometheus Client, so that's one of the points of confusion. But under here, let's do, oh, okay, so it looks like they want more here. Okay. Oops. Okay, so with the requests counter defined, included in the index function, restart the application and make a couple of requests. Okay, so let's restart the application. Boom, our code did not have any errors in it. I did not mistype, despite my unusual keyboard I've got going here. Alright, so let's send a couple of requests. We should see them coming through. So we'll do a metrics request. There we go, got it coming through. Send 2 more metrics requests, 3 more. So we've got 4 requests now. Okay, if the if/metrics is then requested, the output should show some new activity we created. Oh, you know what? Maybe I wasn't supposed to help request total application request type. Yeah, I didn't see that. Oh, no, I see it, yeah. So we added this counter object there. Okay, I see that, cool. Now add a histogram object to capture details on an endpoint that sometimes takes a bit longer to reply. The code simulated by this sleeping for a randomized amount of time. Just like the index function, a new endpoint is needed as well, where the histogram object is used. Okay, so we're going to go back and edit that file again. Now we're going to add a histogram feature. So the first step is here. Okay. The simulated expansive operation will use a function that tracks the start time and end time and then passes that information to the histogram object. Oh, did I forget? Yeah, I forgot a line. I forgot this line here. Okay, and the other thing we did last time was we added just this / here. That means that I can go to this website now with just a / entered in. And we'll, oh, what the heck? I thought it did. Does it not mean that? I thought it meant that. What the heck? Is there like a error? Okay, I guess that's not what that means. Oh, there's an S. Metrics. Oh, and it is just HTTP. This should work, right? I was just here. Oh, you know what? I don't have the Flask server running. I stopped it when I opened up this code. That's why it's not working. Okay. All right, that's fine. We'll go to this once I start the Flask server up again. But until then, I won't be able to go to that. All right, the two new modules are needed, time and random. Those will help calculate the time passed into the histogram and simulate the expensive operation being performed in the database. Running the application once again and requesting the database endpoint will start producing content when metrics is pulled. Several items that are measuring our simulation times should now appear. Okay, so now that I am finished editing it, I can run the server again. And now that the server is actually running, I'm going to have a much better time when I try to reach out to the server. Oops, it is HTTPS, I think. Okay, or not. I don't know what's going on. Oh, you know what? Is it no longer on? No, it is. Okay, now I'm just straight up confused. Now I just don't. Oh, here we go. Okay, perfect. Now we got it. Development Prometheus Flask app. That should look familiar, because that's what we had in the code before. You can also go to metrics again. Perfect, and now we've got our new histogram, hopefully showing up. I don't see it. Ah, we do, down here. All right, so let's go check out that histogram. Not found. Oh, database is what we called it, not histogram. Oh. Okay, so the histogram object is flexible enough that it can operate as a content manager, a decorator, or take in values directly. Having this flexibility is incredibly powerful and helps produce instrumentation that can work in most environments with little effort. Then why is it not showing up? Unable to... Oh, sleep is not defined. Oh, I think I forgot the... Yeah, I forgot the import statement. Yeah, it should be from time import sleep, not import time. Okay, this should work hopefully. But you can see when it didn't work, I did get this nice... Oh, okay, sweet. Completed expensive database operation. Awesome. All right, let's go to metrics. All right. Can we see the histogram? Now, I don't have a histogram. These are the things I can enter in the endpoints. So I can enter in database. I can go to the main endpoint, and I can go to metrics as well. Was I supposed to enter a histogram though? No, I don't think so. Okay, I'm confused. But it seemed to be working. Let's see if we get this. Several items that are measuring our simulation time should now appear. Let's see if we get those items under metrics. Okay, now it's just randomly not working again. Oh, sorry, I don't have the. Okay, it's not. That is not random at all. So we're going to need to get our database operation. There we go. Completed expensive database operation over Google metrics. And there we go. We've got our data. Okay, so next section is going to be on instrumentation. I think I want to end it there. It's been an hour. I don't think I can go much further right now. So, all right, that's going to be it. I'll move ahead the bookmark, and thanks for watching. I'll see you in the next section on instrumentation.